To all my dear students. So today I am going you to deliver lecture about the homologous series that is very important for knowledge as well as examination. So at first we have to know what is homologous series. Homologous series. So that is very important for knowledge as well as examination, generally asking examination in 5 marks. So at first we have to know what is homologous series. So we can say in short, compounds, organic compound, better to say organic compounds containing same functional group are arranged in series on the basis of their increasing molecular weight and having difference of CH2. CH2 is methylene group in between two consecutive compounds are known as homologous series. So I will give you some examples, and we have clear what are the homologous series. So in this case, sometimes ask you what do you mean by homolog. So the member of, it's better to say the individual member of homologous series is known as homolog, and process itself is known as homology. So generally asked in examination, so what do you mean by what you say homolog? So when talk about the homolog, what it means homolog? It is the individual member of homologous series is known as homolog, and process itself is known as homolog, and this process is known as formation of this homolog is known as homology family, we can say. So what you see over here, so we take, so compounds containing same functional group are arranged in series on the basis of increasing molecular weight and having difference of CH2 that is also known as methylene group in between two consecutive compounds means one after another compounds are known as homologous series, and the individual member of homologous series is known as what you see homologue, and process itself is known as homology. Process itself is known as what you see homology. So I am clearing you. So what we have now, we have to see the example of this one. So example of homologous series. Example of homologous series are like this. For example, first one is homologous series of alkane. So you know its general formula. Its general formula is CnH2ICN plus 2. What the general formula of this? So what you see CnH2ICN plus 2. So example, if suppose N is single, yeah, 1. So what we have? 2 into 1 plus 2. So what we have? CH4. That is known as methane. How many carbon over here? 1 carbon. So we can say methane. Methane. Like this, if carbon is 2, so what we have? 2 into 2 plus 2. So what we have? CH3, CH3. So how many carbon? 2 carbon. So what we have? Ethane. Like this. C3, 2 into 3 plus 2. So how much? CH3, CH2, CH3. So what is it? That is known as 3 carbon over here. That is propane. Likewise, C4, 2 into 4 plus 2. So what we have? CH3, CH2, CH2, CH3. So what we have? Butane. So that is homologous series. So that CH4 is known as homolog. Why? Because individual member of the homologous series is known as homolog, and that the formation of this whole series, that is known as homology. So that is about the word see alkane. Next one is homologous series of alcohol. So its general formula is GF. General formula is CnH2 dot OH. So what see if carbon is 1, so what we have? CH3 OH. CH3 OH, what we have? What the name of this compound? Methanol. If carbon is 2, so how much we have? CH3, better to write what you see? CH3, CH2, OH. That is propyl alcohol. Sorry, not propyl. That is ethanol. How many carbon? 2 carbon. So what do we write over here? Ethanol. We are talking about the second example over here. Homologous series of alcohol. So what the general formula? CnH2 plus 1 dot OH. So when we take what you see, carbon is 1. So what do we have? CH3OH. What the name of this compound? Methanol. CH3, how if carbon is 2. What do we have? CH3COH. If CH2OH, that is propanol. If fourth, what we have? CH2, CH2, CH2OS. That is what you see. Butane, we can say 1-ol. Yes, that is about the what see IPAC name of this compound. So according to definition, what we have taught you, those organic compounds containing same functional groups. In all cases, what do you see? Same functional group, and what do you see containing the difference between methane and ethane is what you see? CH2. Ethane and propane is what you see? CH2. Propane and butane is difference is CH2. Always the difference in between two consecutive compound is always CH2. That is CH2 is known as methylene. Likewise over here CH2, what the difference over here? CH2. What the difference over here? CH2 means methylene group. Methylene group. What the difference over here? CH2. Yes, always. So that is the main properties of this what we see homologous series. So in between the difference between two compounds, consecutive compounds are always CH2. So always we have to keep in mind. So that is about what we see homologous series of alkane. So always we have to follow this general formula. Next one is homologous series of alcohol. General formula is this one. So you have to follow this. These all are known as homologous series of alcohol. These are known as homologous series of what you see? Alkane. Yes. So now we have to see its character. What we have to see? Characters of homologous series. Characters. So what you see over here? Homologous series characters. So first character of what you see homologous series are not like this. First one. So all the homologous series follow same general formula. So first character is all the homologous series follow same general. So when we talk about the alkane, so always this it follows CnH2 plus 2 general formula. Like this, when we talk about the homologous series of the alcohol, it's always GF means general formula. So it always follows CnH2 plus 1 dot OH. So these are the example. Yes. So first character of any homologous series, always they follow same general formula. So you have already seen in alkane, you have already seen in homologous series. Now second character is the difference in between two consecutive compound is CH2. That is also known as methylene group. Methylene group, or we can say or 14 AMU. 14 AMU means 14 molecular difference. When we talk about the methane and what is ethane, difference is what you see 14. In this difference 14 AMU. AMU means atomic mass unit. In this case also how much? 14 AMU. Yes, in this case what we have? Same 14 AMU. In this case also 14 AMU. So second character of the any homologous series is the difference in between two consecutive compound means the difference between methane and ethane is always CH2. Yeah, we can say 14 AMU. Better to say 14 atomic mass unit. Yes, difference between the ethane and propane is CH2, or we can say 14 AMU. What do you see? The difference between the propane and butane is how much? 14 AMUs. Always we have to keep in mind. Like this formula and that formula. In both cases we will get the same characters. Now third characters. They homologous series. They have similar general formula. Same general, what you see, preparation. Preparation. Why? What the reason over here? Due to presence of same functional group. For example, over here, what you see over here, suppose you talk about the alcohol. Suppose methyl alcohol. So when CH3, so what the name of this compound? Methyl chloride. When this is treated with aqueous KOS solution. What do you mean by aqueous? Solution made in water is known as aqueous. So what do we have? So you know the electrophile, that is the nucleophile, you know. So what do we have? K react with this one. So what do we have? Minus, so that reacts with this, what is KCl. So what product we have? CH3OH plus what you see? Side product is KCl. So that is known as methanol. Likewise, when we talk about C2H5Cl, Cl plus aqueous KOH solution. Solution means solution made in water. So what we have? Now we have cleared the difference between. So what do we have? C2H5OH plus what you see KCl. So what do you see over here? So if we prepare what you see methanol, what we have to use? Methyl chloride. If we use what you see to prepare what you see ethyl alcohol, then what we have to use? Ethyl chloride. What the name of this compound? Ethyl chloride. Yes. If you suppose propyl alcohol, then what we need? Propyl chloride. What if we need what you see? If we want to prepare what you see butyl alcohol, so what we have to use over here? Butyl chloride. So what you see? They have similar general preparation. Better to say general preparation. Why? Due to presence of same functional group. What the reason over here? Because in all cases, what we see? Same OH, alcohol functional group, we can say. So that is about the third character. Now the fourth character is they have similar chemical properties. Why? Due to presence of what you see? Due to presence of what you see? Same functional group. For example, suppose we take methyl alcohol. What the name of this compound? That is methyl alcohol. When that is treated with phosphorus trichloride, that is phosphorus, how many chloride over there? 3. trichloride. What we get? CH3Cl plus H3PO3. What the name of this compound? Phosphorus. That is phosphorus acid. Likewise, when you talk about the ethyl, that is ethyl alcohol, or we can say ethanol. So when react with phosphorus trichloride, so what we have? C2H5Cl plus H3PO3. What the name of this compound? Ethyl chloride. And what the name of this compound? Phosphorus acid. So what we observe over here? They have similar chemical properties. Why? Due to presence of same functional groups. In this case, what we have? Same functional group, alcohol. So what it gives? Generally similar chemical property. When methyl alcohol is treated with phosphorus trichloride, what we have? Methyl chloride. When ethyl alcohol is treated with PCl3, phosphorus trichloride, what we have? Ethyl chloride. If what is the propyl alcohol, so what we have? Propyl chloride. If butyl alcohol, what we have? Butyl chloride. So they have what you see over here. So they have similar chemical properties. Why? What the reason over here? Due to presence of same functional group. So we are familiar with 4 characters. Now the last important characters are like this. 4, 5. There is gradual change in physical properties like melting point, density, boiling point. BP means boiling point, etc. When we go from top to bottom in the same homologous series. So what it means? So when you go from top to bottom, so what its melting point? MP means melting point, density, boiling point, etc. When we go from top to bottom in the same homologous series. Why? Due to increase in molecular weight. Likewise, for example, what we have? For example, ethane has more melting point or boiling point. Yeah, better to say ethanol. Simple example, ethanol has higher boiling point than methanol. So what do you see? Methanol. Methanol means CH3OH. Why? What the reason over here? So when you go from top to bottom in the same homologous series, what do you see over here? See, its molecular weight increases. If its molecular weight increases, so what is its melting point, boiling point, density, all properties, what you see? Increases. What the reason over here? Due to increase in, reason is what you see? Due to increase in molecular weight. Why? Due to increase in molecular weight. So, when we talk about the homologous series, what we have to, at first we have to know what the definition of homologous series. Then we have to give the example, suitable example. Then we have to also define what is homology and homolog and what is homology. Homology is the process. Homolog is the individual member of the homologous series. Yes, just when we talk about the alkane, methane is the one of the homolog. Ethane is the one of the homolog. Likewise, when you talk about the alcohol, methyl alcohol is individual homolog. What do you see? Ethyl alcohol is homolog, and this whole process is known as homology. So, I think you have clear what is homologous series, what is the 5 characters of what you see homologous series. So, generally ask you examination. So, question is like this. So, what do you say? Define homologous series, homolog and homology with suitable example. Yes, define. And what you see, sometimes write down its 5 important characters. So, I have already told you. So, what is homologous series, what is a homolog and what is homology. So, we have to define all these terms with example. Next, write down its 5 important characters. So, I have already told you from first to last. The first is, so in a brief, so remind you, first one is they always, what is it? They have always similar general formula. Second, the difference in between 2 homologous series is generally CH2, that is methylene group, or we can say 14 AMU. Third one is they have similar general preparation. Why? Because they have similar functional group. Next one, they have similar chemical properties. Why? Due to presence of same functional group. And last one is there is gradual change in physical properties like melting point, boiling point, density when you go from top to bottom in the same homologous series. I think you can write the answer of this question. So, sometimes examination asks you like this. So, what you say, question model. So, this table includes alcohol functional homologous series like what you say CH3OH, CH3, CH2OH. So, yes, we have to find. Fourth one is CH3, CH2, CH2OH. That is the table. So that is known as methanol, that is ethanol. Third one we have we have to find out this one. Fourth one is what you see, butanol. We have to find out. So what you see in this case, ask you examination. In 5 marks generally ask you. So at first define homologous series. Define homologous series. So I have already given you the definition of homologous series. Second one is find the molecular weight of X compound. Third one is write at least 3 characters. Fourth one, what is prefix? What is prefix and suffix of alcohol homologous series? So these are the questions generally asked in examination. So if I have to find the value of what is X, so what the value of X? So how many carbon? 2 carbons. So what we have? So in this case, what is this? CH3, CH2, CH2, OH. We have to find the what is the molecular weight. So how many carbon? 1, 2, 3. So how much? 36 plus how many oxygen? How much? Yes, oxygen 16 plus hydrogen how much? 3, 2, 5, 2, 7. So what you see? So 1, 2, 3. So what you see? 12. 12, 3 is what you see? 36. Oxygen, you know, what you see? 16. And how many hydrogen? 3, 2, 5, 2, 7 and 1. So what you see? 8. So when you add, so how much? 8. So 6, 6, 12, 8, 20, 3 and 1, 4, 2, 6. What to get? Its molecular weight is, its molecular mass is how much? 60. Yes. So you can find the value of molecular weight of these compounds. How much you get? 60. Next one is, third one is butanol, you know. Next one is, you can write what you see, at least 3 characters. Fourth one is, what is prefix and suffix of alcohol homologous series? So that is very important point. So prefix, so other than major functional group. Suppose CH3, CH3, CH2OH. Yes. So in this case, this methyl group is prefix. Methyl group is prefix. So what you see? That is the branching of that carbon. That is not the major functional group. And what you see? Suffix. Suffix over here is what you see? All alcohols. What we have? Secondary suffix of alcohol is all. So alcohol, what we have? Alcohol, at last what we get? OL. So what the secondary suffix of alcohol? All. OL, all. So I think you have clear, you can solve the question in the examination. So very simple. If you know all the basic things, you can describe easily. Yes. So that is about the question, answer of this question. So we have clear what is the prefix. Prefix means any branch of the main chain, that is known as any branch of the main chain. So in this case, CH3 is the branch. So what we have? Prefix is over here. Methyl, that is also known as methyl. Suffix is alcohol. Yes, I think you have clear. And what type of question is asked in the examination. Yes. Next one is, what is what is catenation? Catenation, yes. What is, very important term, what is catenation? So, catenation is self linkage of carbon atoms to form long, maybe linear chain, maybe branch chain, maybe cyclic compounds through what is the covalent bond. What the reason? Due to, what the reason over here? Due to a smaller size of the carbon atom. So, catenation is also seen in what we see in organic compounds like sulfur, silicon, like this. But in generally carbon, organic compounds generally, so in case of carbon atoms to form long linear branch cyclic compounds through covalent bond due to why? Due to a smaller size of the carbon atom. Yes, so always we have to keep in mind that is self linkage. So example is like this. So what you see, CH3, CH2, CH2, CH3. So that is linear length, what you see, chain compound. Example is, for example, so what the name of this compound? 1, 2, 3, 4, 5. So what the name of this compound? Pentanes. That is the linear chain. We can say linear chain. One example. Two example is CH3, CH3, CH2. That is 2 methyl. What do you see? How many carbon? 1, 2, 3, 4. So what we have? Butane. Like this. These all are carbon. All are carbon. Yes. And you know carbon is always tetravalent. What we have? H. This dot is carbon. What the name of this compound? Cyclohexane. Yes, so these are the example of what we see, organic compound, in which what we see, so these all compounds form. Why? Due to catenation. Catenation means what we see? Self linkage of carbon atom. Why there is self linkage of carbon atom? Because the size of the carbon atom is very, very low. So it always forms catenation, and due to catenation what we see, we get different type of linear chain, sometimes maybe branch chain, sometimes maybe cyclic ring. These all are the example of organic compounds. In organic compounds, catenation is seen generally. So I thank you all students for watching this video. Now I will come with next video, that is what we see, ozonolysis. Then I will talk about the Marconi-Krebs rules. So that is very, very important for you, for your knowledge and what we see examination. Today is okay.